Year 13 revision, short revision video 2. So we're going to start off with a differentiation question. Now notice the question says we must show detailed reasoning. That means we need to make it very clear as to how we complete each part of this question. So the equation of a curve is given by this function over here, and we've got to find the equation of the tangent at the point where x equals 0. So it's clearly a quotient, so we can differentiate this using the quotient rule. So I'm going to say that u is equal to ln of x plus 2, and v is equal to cos of x. Now, du by dx, it's an ln function. We know that differentiates to a reciprocal, so 1 over x plus 2. We then need to multiply by the derivative of the inner function, but that is just 1. So that doesn't alter the answer. And then dv by dx, we know that if we differentiate cos of x, we get negative sine of x. Now, our quotient rule formula tells us that dy by dx is equal to v multiplied by du by dx. Take away u multiplied by dv by dx. And all of this is divided by v squared. So let's substitute in the information. Dy by dx is equal to v times du by dx. So that's going to give me cos x over x plus 2. Take away u multiplied by dv by dx. So over here. Now this is going to give me a minus minus because of the minus sine x here. So I'm going to end up with a plus sine x ln of x plus 2 all over v squared, which is cos squared x. Now let's work out what's happening at x equals 0. So at x equals 0, we can work out that dy by dx is equal to 1/2. Now we want the equation of the tangent. So we also need to work out the value of y. We have x, we have the gradient, we need to know what y is. So at x equals 0, substituting that into this function over here, we have y is equal to ln 2. So we can then use our equation for a straight line here. And we get y minus ln 2 equals 1/2 of x. x1, of course, is equal to 0. So this gives us y equals 1/2 of x plus ln 2. So our next question is an integration question, and we're even informed in the question that we need to use a suitable substitution. It does say or otherwise, but usually the first suggestion is going to be the simplest one. So I'm going to choose u equals 2x minus 1, so the denominator. I can then differentiate this, so du by dx is equal to 2, and then I can do my faux rearrangement, that dx is equal to du over 2. Now, I have a pair of limits as well that I will need to deal with at some point. So if I look at my lower limit here, if x is equal to 3, I can use my substitution here to work out that u is equal to 5. And if x is equal to 8, I can work out that u is equal to 15. Now, looking at my integral here, this then becomes the integral between 5 and 15 of 2x over u. And then in place of dx, I can use du over 2. Now, it's probably going to be tempting at this point to cancel the 2 here with the 2 here, but I am going to leave that for the moment because I have a 2x here, and that makes it very much easier to put back in terms of u. I have to do a little bit more algebra if I first of all cancel the 2's, so just making life a little bit easier for myself here. So going back to this substitution here, u equals 2x minus 1, this of course tells me that 2x is equal to u plus 1. So going back to my integral, I'm going to pull a factor of 1/2, so this 2 in the denominator here outside of the integral, my integral between 5 and 15, And then in place of the 2x at the numerator, I'm going to put u plus 1. So I have u plus 1 over u, all being integrated with respect to u. I now need to divide both parts of the numerator by u. So that gives me 1 plus 1 over u. And I can now perform my integral, my definite integral. So I get u plus ln mod u, although both the limits are positive, so this won't be required, the modulus. So this gives me a half, 15 plus ln 15, take away 5 plus ln 5. Now simplifying this gives me a half of 15 take away 5 is 10, ln 15 take away ln 5 is of course ln 15 over 5, which is ln 3, and this then expands to give us the required answer of 5 plus ln 3. We may need to show a little bit more detailed working than I have done here, in which case make it clear that you have ln 15 take away ln 5, which is ln of 15 over 5, which is ln of 3, using our log rules. So the third question is a short mechanics question. We have a bus travelling on a straight road accelerating uniformly from 2.5 metres per second to 7.5 metres per second in 12 seconds. It then travels at 7.5 metres per second for 20 seconds before it slows down uniformly to rest in 8 seconds. So for part 1, we're going to sketch a velocity time graph for the bus. So let's start off by sketching some axes for this. So we know that the bus starts at a speed of 2.5 and it accelerates uniformly, so constant acceleration means a straight line velocity time graph, up to 7.5 metres per second. So we can draw that in. So there is our 7.5 marker. And that takes 12 seconds. So if this is 0, I can mark on 12 over here. Now we travel at this speed of 7.5 metres per second for 20 seconds. So I'm going to join that there. Now it's the constant speed of 7.5 metres per second is for 20 seconds, so this gives me 20 plus 12, which is 32 seconds, and then we slow down uniformly to rest in 8 seconds. So that means there's a final portion of the graph which takes us down to 40 seconds on the x-axis. So my x-axis represents time in seconds. My y-axis represents velocity in meters per second. And here is my velocity time graph. Now, part 2 asks us to calculate the average speed of the bus. Now, average speed is equal to total distance travelled divided by total time taken. Now, we need to calculate the total distance travelled, which means we need the area under this graph. Now, there are lots of different ways in which we can calculate this. I'm going to divide this up into 3 regions. So area A is a trapezium. So we want half the sum of the parallel sides multiplied by the distance between them, 12. So we can work out what area A is equal to. Area B is, of course, a rectangle, 7.5 multiplied by 20. And area C is a triangle. We could also have used areas B and C combined as a single trapezium. So the area of C is a half multiplied by the base multiplied by the height of 7.5. So these values work out to be 60, 150 and 30. So the total distance is the sum of all these, and we need to divide that by the total time taken of 40. So it is 240 metres divided by 40 seconds, or 6 metres per second.